So now we're going into chapter 7. Chapter 7 is sometimes more challenging. So you want to stay focused. You want to stay on top of your homework. You want to work every single day. If you get stuck and you don't know what to do, you need to come and see me. Go to SOAR or go to Smart Thinking, or all of the above. Okay, so you want to stay on top of this. Do not put off homework. Do not put off homework. Okay, so rational expressions are fractions on steroids. So they have a lot of the same properties as fractions. But we are using polynomials. We're going to have an algebraic expression in the numerator and an algebraic expression in the denominator. Okay? And all of these are examples of rational expressions. Okay? So here's a polynomial that we know how to factor. And then we have a binomial in the bottom. Okay? A binomial here. And then we have a trinomial in the bottom, and we know how to factor these. So factoring is going to play a key role in rational expressions. Okay. So now let's start talking about when a rational expression is undefined. So I want you to grab your calculators. Everybody grab your calculators. Grab your calculators. And I want you to do 0 divided by 3 in your calculator. 0 divided by 3, okay? And that looks like this. 0 divided by 3 looks like this, okay? Everybody, I want to see your calculators on your desk. Calculator.
I don't have mine. That's why I borrowed one on the test the other day.
Pull out your phone. You have a calculator on your phone. Okay, pull up your calculator. Okay, everybody, 0 divided by 3 on your calculator. What'd you get? 0. Okay, so 0 divided by 3 on your calculator is 0. That is okay. Okay, 0 is totally fine. Now I want you to do 3 divided by 0 on your calculator. 3 divided by 0. Undefined. Okay, what this tells us is that you cannot have a 0 in the denominator. A rational expression is undefined if the denominator is 0. It does not necessarily mean that x is 0. So let's look at this one right here. If I'm focusing on the denominator right here, okay, if I'm focusing on the denominator right here, and I plug 0 in for x, what's 0 minus 3? Negative 3. That's not 0, and so it's okay. So we're not saying that x can't be 0. What we're saying is that the denominator cannot be 0. And so what we do when we are talking about the domain of a rational number is you set the denominator equal to 0. It's okay if the numerator is equal to 0. Okay, so set denominator equal to 0. Set denominator equal to 0. Okay, and that's what we're solving. X minus 3 cannot be 0. So what value of x gives me 0 in the denominator? 3. Okay, so it means that x cannot be 3. So what we're looking for is what value of x makes the denominator 0. That's what we're looking for. We are not saying that x can't be 0. Sometimes x can't be 0, but that's not what we're saying. Okay? Now, here, I am going to focus on this denominator right here, 15x plus 45. And I am going to set that equal to 0. Okay? Now what I want you to do is I want you to solve this. I want you to solve this. Okay? So I subtract 45 from both sides. I get 15x cannot be negative 45. I divide both sides by 15, and x cannot be negative 3. Okay. Now I want to remind you about interval notation. Interval notation. So what we're going to do now is we are going to write our domains in interval notation. Okay, so for the first one, I got that x cannot be 3. And if I think about a number line right here, okay, here's 0. Here's 1 and 2. No, negative 1 and negative 2. And here's 5. Okay? What I'm saying here is that x can be any number up until 3, and then it can be any number after 3. Okay? Now, what number is way down here? What number is this? Excellent, negative infinity. So think about how we would write this using interval notation. Okay? I would have a parentheses, and then I would have the number negative infinity. Then I go all the way to this number right here. What's this number? 3. Okay. Now, does a parenthesis mean that the number is included or not included? Not included. So the parentheses means the number is not included. Okay? Brackets. What do brackets mean? Number is included. So are we going to use parentheses or brackets at positive 3? Parentheses, because our number cannot be 3. X cannot be this number. Okay? Now, who remembers what sign we use? Because we've only accounted for all these numbers less than 3. What sign do we use that says I'm not done yet? What does it look like? It means union. Oh, the U. Okay? That means both of these are true. So then I put a union sign right here. I use parentheses again because 3 is not included. And then I go to infinity. Okay? So, right here, this is my number line. My value of x can be anything except positive 3. It can be anything except positive 3. It can be 2.9999 and it can be 3.00001. It just can't be positive 3. Okay? So this right here is how you write this in what's called interval notation. Okay? And it's telling me that my value can be anything but positive 3. Now, we had our second one was x cannot be negative 3. Okay, so I want you to take about 30 seconds and I want you to write that using interval notation. Interval notation. You do not have to draw the number line. I just draw it as a visual. Okay? Where do I start? I'm sorry? Where do I start? On the number line, I always start down here. What's this? Good. Okay, and infinity and negative infinity always have a parentheses. They always have a parentheses. Where do I go up to? Okay, this number right here is negative 3. Okay, what's the sign to say keep going? Good. Then what do I write down? Good. Okay, that is called integral notation. That will be very key when you get into Math 112. So you want to be sure you've just kind of been exposed to it. You were exposed to it in your algebra courses in high school. You were also exposed to it if you took 098. Okay, but this will be a big deal once you get into Math 112, which is the math course right after this. Okay, now what I want you to do is I want you to take 3 minutes and I want you to do these 3 problems for me. You are finding the domain of these 3 problems. Finding the domain. Correct. Yep. Okay, what value of x makes the denominator 0? Let's go ahead and start talking about these. Look at number 1, or A. Is there an x in the denominator? No. Is it okay if our numerator is 0? It is totally fine if our numerator is 0. Okay? It's our denominator that can't be 0. In this situation right here, our denominator is always 3. It's always 3. Okay? So that means that our domain here is all real numbers. X can be anything, just like in a polynomial, okay? X can be anything. How do I write all real numbers using interval notation? Correct, you're absolutely right. It would be negative infinity to positive infinity. You are absolutely right. The answer to this one is all real numbers. All real numbers. Okay? Okay, now, for the next one, what's in the denominator? Yep, so I've got an x in the denominator, and so I'm going to set x minus 1 cannot be 0. So what can x not be? X cannot be positive 1. So to write this using interval notation, if you want to draw a number line, you can. You do not have to draw a number line. Okay? Here's my number 1. So my x value can be everything to the left. So I start at negative infinity. I go all the way to 1. And then I go 1 to infinity. Okay? Now, factoring is going to play a huge role in this chapter. Okay? Everything that we do in this chapter relates back to factoring. That's why we wanted to master factoring so much, because the second test and the third test are very much related to each other. So here, what we have to do is we have to set our denominator equal to 0. So I have x squared minus 2x minus 15 cannot be 0. So I've set it equal to 0. Now this is a quadratic. This is a quadratic, and how do we solve quadratics? Factor. So we have to factor this. Okay? So now I'm going to do two numbers that multiply together to give me negative 15 and added together that give me negative 2. So I have to factor this. Okay? I don't have to worry about doing the AC method because my A is 1. I can just do my numbers. So I've got x minus 5 and x plus 3. I just factored that. Okay? And so again, if you are not comfortable with factoring, you want to email me, you want to come see me during student hours because we want to beef that up. We want to make sure we've got factoring mastered. So here I've got x minus 5 equals 0. Or it cannot equal 0, and x plus 3 cannot equal 0. So x cannot be positive 5, and x cannot be negative 3. Okay. Now, I'm going to draw a number line just to give us a visual on this. Okay, so it's super, actually I'm going to do this on the next page because it's so important that we understand what we're talking about here. Okay, so we know that x cannot be 5 and x cannot be negative 3. So now I've got a number line. Here's 0. Here's 5. Here's negative 5. Okay. So x cannot be 5 and it cannot be negative 3. So 1, 2, here's my negative 3, and here's my positive 5. Okay. So what I have to do now is I have to do interval notation that represents this number line. So I cannot include 5 and I cannot include negative 3. Interval notation, we always start down here. And what is this right here? Negative infinity. Okay. We always move this direction. So the first number I come to is negative 3. Okay. So I've got negative infinity to negative 3. Then I have to put my union right here. Now, the most common mistake on a problem like this is students then say 5 to infinity. That is the most common mistake. So students have accounted for this part of the number line, and they've accounted for this part of the number line. But students forget this middle part right here. They forget that. So what we need to do is we need to make sure in interval notation we account for this right here. So I start at -3 and I go to 5. That right there is the number one thing that students forget, is they forget this middle part. That's why drawing a number line is helpful. The other thing that students do is because they get 5 first, they'll do -infinity to 5, and then they'll do -3 to infinity, okay? You have to, and this is wrong right here. You can't do that. You have to do it in order. You have to do it in order. Question back here. No? Okay? So if you're not sure how to write it in interval notation, draw a number line. The number line will help you. And it's so important that you remember your number line goes from left to right. Okay. So now what we're going to do is we're going to start simplifying rational expressions. So let's look at this right here. Simplifying a rational expression means writing it in lowest terms or simplest form. It's just like simplifying a fraction, like we did earlier. Okay, we had 2/4. 2/4 simplifies to 1/2. It's the same thing. Okay, it's just a little bit more complex. Simplifying a rational expression means writing it in lowest terms or simplest form. So the first thing that we do is we completely factor the numerator and denominator. So this is why factoring is so important, because everything that we do for the next week and a half, your first step is going to be factor. Actually, for the next, even the week after spring break. Okay, you're going to factor, 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 factor. So when you look at a problem, the first thing you're going to do is factor. Okay, so you're going to completely factor the numerator and the denominator. Then you're going to divide out factors common to the numerator and denominator. Sometimes you might hear that called canceling. Okay, you might hear the term canceling. The other thing to think about, if it's in the top and the bottom, you can cross it out. Okay, so if common to top and bottom, cross it out. Okay, if it's common to the top and the bottom, you cross it out. Okay, we ready to do this? What's the first thing we're going to do in every single problem? Factor. Okay, so right here, I want you to factor this problem right here. There's a GCF in both of those. So I want you to factor it. Just factor it on your paper right now. Okay, what comes out of the top? Okay, so I'm going to factor out a 7, and then I'm left with x plus 5. What's the GCF in the denominator? Okay, and then I'm going to factor out an x plus 5. If it's common to the top and common to the bottom, I cross it out. Okay, so then my final answer to this is going to be 7 over x. Okay. So hopefully we're all comfortable with factoring, and we can look at that and then we can just factor. Okay? Now we're going to do the next one. X squared plus 3x minus 4 and x squared minus x minus 20. So we are going to factor the top, and we know how to factor. We've mastered factoring. Okay? So in the numerator, I've got a product of -4 and a sum of +3, and I have a coefficient of 1 right here. So that is a straightforward factoring. Okay? So I factor and I get x minus 4 and x plus 1. Nope, I did that backwards. It's x plus 4 and x minus 1. Okay? Same for the bottom. I've got negative 20 as a product, negative 1 as a sum. So that's going to factor to x plus 4 and x minus 5. Okay, if it's common to the top and common to the bottom, we can cancel it out. So my final answer right here is x minus 1 over x minus 5. Now, if you are struggling with factoring, there is still time to master that. But we've got to start mastering it well before spring break. So then you can work on it over spring break. Smart thinking is opening over spring break. So if you have not mastered factoring, please, please, please come and contact me immediately, and then we can get you going on that. I'll have your tests graded in the next couple of days, and that'll give you a really good idea. But factoring is so important, so, so important. Okay, and I know I told you that during our factoring unit, but now you can really see the difference that it makes. Okay? Now, these two problems are sometimes ones that students struggle with for a couple of different reasons. What we have to do in both of these is we have to factor out a negative 1. We have to factor out a negative 1. 7 minus y and y minus 7 are not the same thing. If it was addition, it would be the same thing. But this is not the same thing. Okay? So what we have to do here is we have to factor out a negative 1. And sometimes that confuses students. So what we're going to do right here is I am going to factor out a negative 1 in the numerator. I'm going to leave my denominator alone, but I'm going to factor a negative 1 out of the numerator. Negative 1 times what's going to give me positive 7? Good, negative 7. Negative 1 times what is going to give me negative y? Good, positive y. Now, all I did here was I factored out a negative 1. Okay. Now, I'm going to do a rewrite. Don't skip steps here. Do not skip steps. So in my rewrite, I'm going to keep my negative 1. But what I'm going to do is I'm going to rewrite this as y minus 7. Okay? That's what I mean by a rewrite. I'm rewriting that as y minus 7. And then, do I have something on the top and the bottom that I can cancel out? What is it? Good. And so my answer to this is negative 1. Negative 1 is my final answer to this right here. Okay? Now, a clue for when you start factoring out. A clue for when you start to factor out is going to be this right here. Do you see how you've got your constant here, and then you are subtracting your exponent or your variable with an exponent or your variable? That's an indicator that you're going to factor out a negative 1. So I'm going to do that here. So I've got negative 1. Because I'm factoring out a negative 1, what does this 4 become? Okay. Then what does this become? Okay, so what I've done right there is I have factored out a negative 1. Okay, all I did right there is I factored out a negative 1. Now I'm going to do the rewrite. So keep my negative 1 on the outside, and I have x squared minus 4. Okay? Now, I am going to rewrite this on the next page. Okay? I'm just going to rewrite this on the next page. So I have negative 1 x squared minus 4 over 3x squared minus 5x minus 2. Okay? This is difference of perfect squares right here. So I'm going to have negative 1. Keep your negative 1. And I've got x plus 2, x minus 2. This is a little more complex for your factoring, so I need to do it off to the side. Why is this more complex? I have a coefficient that is not 1. That's why this is more complex. So let's remind ourselves how to factor using this process. 3 times negative 2 gives me a product of negative 6. My sum is negative 5. Now, be careful here, because with a sum of negative 5, you might be thinking negative 2 and negative 3 are your numbers. But negative 3 times negative 2 gives me positive 6. I don't want positive 6. What do I want? I want negative 6, okay? So I need two numbers multiplied together that give me negative 6 and added together. Good. It's negative 6 and positive 1. So that's what we're breaking this up to, negative 6 and positive 1. So now I've got 3x squared minus 6x plus 1x minus 2. Okay, 3x comes out of both of these, so I'm left with x minus 2, and 1 comes out of the others. Okay, so I have 3x plus 1 and x minus 2. Okay, so I have 3x plus 1 and x minus 2. Okay, so our x minus 2 cancels. Negative 1 times x plus 2 over 3x plus 1 is correct. That's 100% correct right there. However, if you distributed the 1 or distributed the negative 1, that would be okay. Okay? So either one of these answers are 100% correct. Okay? Both correct. Both are correct. Okay?